Using the graphs below, we're going to write an equation for G, that's the first one, for H, that's the second one, and for K, and that's the third one. And so each problem is a different function. So they give us F, it's based on the graph of F, and they want to know, what did you do to F to get G? What transformations took place? Did you multiply by something and scale it? Did you multiply by a negative and flip it over? Did you shift it horizontally? Did you shift it vertically? So that's what we're doing, and I've already written a little bit on this one, and what I wrote basically is just the basic shell of what we're going to be doing. So here's what's really going on. I'm going to figure out, is there a number that goes in the front of F? You don't have to write this. Is there a number that I would add or subtract to X to move it horizontally? Is there a number that I would add or subtract to shift it up or down? And I need to figure out what, if anything, goes in these little boxes. I don't know what that would be, so I've left some gaps here. So let's figure it out. Take a look at F, and let's see what we did. Now, I think the obvious is that we slid this thing sideways, right? So we have a horizontal shift, and that horizontal shift went to the left, and left would be negative, but not in this context, okay? So we have that going on. So there's a number that's going to go here, and we have to figure out what that number is. And let's take a look at this point right here. This is a maximum. Well, it's what we call a relative maximum. A relative maximum, you'll encounter this vocabulary later. I might be getting ahead of myself with some vocabulary, but relative maximum is when we have basically a maximum, but it doesn't have to be the highest point on a graph. Like the highest point on this graph actually is infinity because it goes up forever. But this is a relative maximum, but it actually corresponds to this, which is a relative minimum. So what was a maximum became a minimum. It sounds to me like this graph got flipped over. Okay, and if you don't notice that, that's okay. Take a look at this point. This was a minimum, and its corresponding point now is a maximum. So what was down here went up here. So if we didn't slide this thing this way, then what we would have is a graph, and I'm going to draw it very lightly. It would go up like that, and down like that. It would look like this. It would basically be flipped. It looks terrible. You can barely see it. But it would basically be flipped over. So I'm going to erase what I just did. That was probably not helpful at all. And I am going to go ahead and put a negative in the front because this graph got flipped over. And when it got flipped over, what was 4 down now is 4 up. What was at 0, well, stayed at 0. But what was going down now is going up. See, it's going up. But then it also got slid over. We've already put a sign in here. So how far did it get slid over? Well, that turned into, let's see, 1, 2, 3, 4, 5, 6. So it slid over 6. Let's just confirm one more time, though. This coordinate corresponds to that one. So 1, 2, 3, 4, 5, 6. Yeah, all right. Here we go. Let's go to the next one, and it's the same idea. H is something that involves F. So what really happened here? Well, we obviously have a horizontal shift, and we have a vertical shift as well. So now there's also a question of, did we stretch this thing, shrink this thing? Did we flip it over? And let's go for the obvious. We did not flip it over. You could trace it with 2 fingers and realize what's happening here. It did not get flipped over, okay? It's perfectly fine. It does not inverted in that context. So we have f of x. Put something in there with that. Do we have a number in the front though? Did we stretch it? Did we shrink it? Okay, let's just look at the scale of this thing. From this minimum to this maximum was 4 units. From minimum to maximum was 4. So no, there's not a number in the front. I left a gap there for no reason at all. Okay, let's go. I would go from here to its corresponding part, but that's kind of hard to see where that is. I like to use maximums and minimums for this. So let's use this maximum. And so we are going to go 1, 2, 3 to the right. Okay, that's horizontal. 3 to the right. Change signs. And then we went 3 to the right, and then to get to that corresponding point, we went 1, 2, 3, 4, 5 up. So plus 5. Got it. That was it. That's it. We slid 3 to the right, 5 up. You could check other points as well. From here to here was 1, 2, 3 to the right, 1, 2, 3, 4, 5 up. All right, last one. K is equal to, and then there's some F stuff involved. There's an X and horizontal shift and vertical shift and stretch and shrink and negative and maybe this and maybe that and maybe not. Okay, here's F. Let's use that relative maximum point to correspond to this one, and let's just figure out what's happening. I think we can go for the obvious that there was a horizontal shift. Horizontal shift went 5 this way, 5 more, so 10. 10 to the left. That 10 to the left is going to be plus 10. Okay. Did it slide up or down? No, it did not. Did it flip over? No, it did not. Now, flip over is not the mathematical term, but we did not negate the function, make it negative by changing the sign. Well, not make it negative, but multiply it by a negative, which would flip it over, which is what happened in the first case. It got flipped over and slid. But in this case, it didn't. So it's down, then up, then down again. But we do see a difference in scale. So even though this is not a negative number, and even though we are not shifting it up or down, we do have the situation here where what was down 4 is now down 2, okay? So this point right there, that down 4 is now down 2. So we are dealing with a scale. So do we double it? No, we don't double it. We halved it. And if you want to find other corresponding points, you can. I'm going to just point out one that's a little bit more obscure. Let's go, I'm trying to find one that would just land exactly on a grid mark. It's kind of hard to do, but this may not be exactly on a grid mark, but I'm going to take my best guess. That coordinate right there looks like 6, -4. Well, its corresponding point, if we slide the 6 over, we're going to be at -4. Slide it over 10 to the left. And then instead of going down 4, we'd go down 2. See? So it is half.